A box plot, also called a box and whisker plot, is another way of looking at a dataset to determine its central tendency, spread, skewness, and the existence of outliers. A box plot is a set of 5 summary measures of the distribution of the data. First, the median of the data. Second, the lower quartile. Third, the upper quartile. Fourth, the smallest observation. Fifth, the largest observation. The hinges of the box are the upper and lower quartiles, the rightmost and leftmost side of the box. The median is marked as a vertical line across the box. The whiskers of the box plot are the extended lines from the upper and lower hinges to the largest and smallest observations, called the upper whisker and lower whisker. The largest and smallest observations must be within a distance of 1.5 times the interquartile range from the appropriate hinge or the quartile. The interquartile range IQR is the distance from the upper quartile to the lower quartile, the length of the box from hinge to hinge. Mathematically, IQR is equal to upper quartile QU minus lower quartile QL. Interquartile range means half the data are within the box. The points at a distance of 1.5 times of interquartile range above the upper quartile and below the lower quartile are inner fences. The whiskers are extended to the largest or smallest observation, that is at a distance less than or equal to 1.5 times the interquartile range from the hinge, so that the smallest data point couldn't lie below the inner fence and the largest data point couldn't lie above the inner fence. If one or more observations are further away than that distance, they are marked as suspected outliers. The points at a distance of 3 times of interquartile range above or below the appropriate hinge are outer fences. The observations are at a distance of over 3 times the interquartile range from the appropriate hinge and are marked as outliers. Box plots are very useful for statistical data analysis. The box plot is used to identify the location of a dataset based on the median. The box plot is used to identify the spread of the data based on the length of the box, hinge to hinge, the interquartile range, and the length of the whiskers, the range of the data without extreme observations such as outliers or suspected outliers. The box plot is used to identify the possible skewness of the distribution of the dataset. If the portion of the box to the right of the median is longer than the portion to the left of the median, and or the right whisker is longer than the left whisker, the data are right skewed. Similarly, a longer left side of the box and or left whisker implies a left skewed dataset. If the box and whiskers are symmetric, the data are symmetrically distributed with no skewness. The box plot is used to understand the variance of the data based on the length of the box and whiskers. The box plot is used to identify suspected outliers, observations beyond the inner fences but within the outer fences, and outliers, points beyond the outer fences. The box plot is used to compare 2 or more data sets. By drawing the box plots on the same scale, we can compare several data sets, such as data sets A and B seem to be similar and data sets C and D are not similar. That's it in this video. Hope it was a great learning for you. In next video, we will learn how to construct a box plot for a given data set. If you have any doubts, then drop your thoughts in the comment box below. Hit the like button and share this video in your circle. Subscribe to Shake Hand with Life on YouTube, LinkedIn, Facebook and Telegram. Thanks for watching.